So today we're doing 3.7b, still dealing with absolute value, and now instead of equations, yesterday we did equations, right? Today we're doing inequalities. So now we're back to the less than, greater than, less than or equal to, greater than or equal to, okay? The beautiful thing about this is the concepts, you have learned all of them. Now it's just that we have to put them all together, and sometimes that gets a little difficult because there's a lot of concepts then, right? So just making sure that we don't forget any of the little pieces is where some of the trouble can lie. But I do want to show you a little trick when it comes to absolute value and inequalities, and it is this. When you see a less than symbol, okay, so when you see less than or equal to, here's what I want you to think when you see it. You're going to think less than, okay? I'm going to put a D at the end of this, less than. So when it's less than, it's an and, an and problem when there is absolute value involved, okay? When you see greater than, actually we're not going to put the than in here because I don't want to throw you off. When you see greater than, okay, so when you see this symbol or that symbol, I want you to think that this is an O instead. Think greater. Instead of greater, greater. So that's an or problem. This is an and problem. Okay, so when there's absolute value and then a less than and then some number, that's an and problem. Okay, when there's absolute value, a greater than or equal to and some number, that makes it an or problem. Okay, so that's just a little trick that you can use. You don't have to use the trick. You'll be able to do it without it, but if it helps you just to remember which is which, you can totally do that. All right, so here's how we do absolute value stuff. When you have a less than or equal to, greater than or equal to problem, okay? So an inequality problem. If we divide by a negative, what do? Flip your sign. If you multiply by a negative, what do? Flip the sign, okay? So think about what we've been doing with absolute value. When we have an absolute value problem, we say the absolute value of something is equal to some number, right? We take away the absolute value and we write how many equations? Two. One that's positive and one that's negative. Well, for the one that's negative now, you're going to have inequalities instead. When it's negative, you're going to flip it, just like we flipped when we multiplied or divided by a negative number. Okay, so let me show you what I'm talking about because it'll make a lot more sense when you just see a problem like it. So this is like example 4 in the lesson. If we have this setup, the absolute value of 8n is greater than or equal to 24. Okay. Yesterday, if we saw this problem, there would have been an equal sign in between. Okay, what would you have done yesterday with the equal sign? The two equations, right? You would have said 8n equals 24 and 8n equals negative 24, okay? Today, the only difference is this, okay? We have a symbol in there now. So we're still going to write two inequalities, but you make one negative, and instead of leaving them both as this symbol, you're going to leave this symbol here. But here, in the negative one, you're just going to flip your symbol. That is the only thing you're going to do different from what we did yesterday, okay? So you would write from this setup, you would write 8n is greater than or equal to 24, okay? So that's your first inequality. Your second one, we're going to say 8n is less than or equal to. So flip it around and make it negative 24. Does that make sense? So if you consider what we did yesterday, the only difference is you're going to put a symbol here and the opposite symbol here. The symbol that goes in the first one, the positive one, is the one you started with. The symbol that goes in the second one is the flipped version of that. Okay? So if we solve this, divide by 8, we get n is greater than or equal to 3. Okay? Divide by 8 here, we get n is less than or equal to negative 3. Okay? Now here's my question. Is this an and problem or an or problem? It's or, right? Because this is greater, right? When it's greater than or equal to, we think greater. It's an or problem. Think about what it's saying here. And you don't need to know it from the shortcut. If I were to graph this, you have a 3 and you have a negative 3, okay? N is greater than or equal to 3. Is that an open or a closed dot? It's a closed dot at 3. What direction is my arrow going? It's going to the right, right? N is greater than or equal to 3. Okay, so this would be the graph of this one. The graph of this one, open or closed dot? Closed dot. And n is less than or equal to negative 3. Where am I going with that? To the left or to the right? To the left, because it's got to be less than. Okay, so that's how you can tell this is an or problem. It's like the oars on a boat. They go out to the side, you row, right? That's an or problem. Okay, what would you do with this problem then? So absolute value needs to be isolated. Is it isolated here? It is. Okay, so you can write your two inequalities. How do I write my first inequality? Equals, because you're going to use your symbols still. Greater than or equal to 5. Okay, so the first equation, you guys, or inequality, the first inequality is going to look exactly like the one you started with. You just take away your absolute value bars. Okay, what does the second one look like? A negative and flip it. Okay, so still 2x plus 4. We're going to flip our symbol around and we're going to make it negative. How do I solve those? Let's do the green one. How do I solve the green? Take away 4. So you get 2x is greater than or equal to 1. Then what? Divide by 2. So x is greater than or equal to 1/2. Okay? All right, second one. What do I do to solve? Take away 4. So I get 2x, this is gone, is less than or equal to negative 9. Divide by 2. So x is less than or equal to negative 4.5. Okay. Is this going to be an and problem? Are we going to shade in or an or problem? Shade out.
Shade.
It's or because it was greater, right? That's an or problem. So when you graph this, you have, if this is 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is negative 5. This is 0. This is 1. If I plot my points, x is greater than or equal to 1/2. So here's 1/2. Okay, it's a closed dot. What direction is my arrow going? To the left or the right? That's going to go to the right. Okay, because it's greater than. Then you have a negative 4.5. So that's going to be here. Closed dot, and its x is less than that. So we're going to go to the left on that one. Okay, so that's another or problem, going out to the sides. Questions on that? Okay. How about this one? Is this going to be a and or an or problem? It's going to be an and problem, right? It's less than. Think less than. So what are your two inequalities going to look like? What's the first one?
X minus 9 less than
Or equal to 12. Okay, so the first one, like I said, you're just taking away these two bars, right? That's all you're doing on that first inequality. What's the second inequality going to look like? Flip the sign and make it negative. Okay, so really you're doing two steps. Flip the sign, make it negative. Does that make sense? Okay, so if we solve this, we're going to add 9 here, add 9 here. So this is gone. I'm left with x is less than or equal to 21. Okay, then on this one, add 9, and I'm left with x is greater than or equal to negative 12 plus 9 is negative 3. Okay, now here's the thing on this one, guys. When it's an and problem, remember we said we could write it in a simpler way. You don't have to do that for me. I'm fine if you want to just leave them like this. But if you want to write it the simpler way, make sure it's always your smaller number is at the beginning, okay, your negative 3. Your bigger number is at the end. And then your symbols will always be less than or equal to with your variable in between. So you may give me this as an answer, or you may give me this as an answer. They're both acceptable, okay? But you do have to graph them. So if we graph this, you have a negative 3, a positive 21, closed or open dots? Closed, because they have those equal to. Okay, so closed dots. And do I shade in or do I shade out? I said it's an and problem, right? You shade in, okay? And if you aren't sure, just look back up at these. X is less than or equal to 21. Less than 21 is going this way. Greater than negative 3 is going this way. So where they overlap is all of that dark shading. Okay? Any questions on that? Okay, that's the concept. Just know that these ones, because you're so used, like, if you follow the progression, right? We did, what was the first? Before the absolute value. We just did solving equations, solving inequalities, then we brought in absolute value equations. Now it's absolute value inequalities. So you've had this progression of things that we're doing. You just have to make sure you can keep them all straight, okay? So with absolute value inequalities, flip the symbol, change the sign to a negative, and those will be your two inequalities that you'll write, okay? All right, you have a good chunk of time right now.